Hi everybody, again, thank you for watching Gaffer and Gear. In today's episode, I'm reviewing the ARRI Sky Panel X. So this light has an IP66 rating, so you can use it out in the rain. It has the largest CCT range of any light that I've ever tested on Gaffer and Gear. Its top end is 20,000 Kelvin, and its bottom end goes all the way down to 1,500 Kelvin. Now this light has the capability of dimming down to a true 0.1%, and even at 0.1% it has higher color render scores than the original Sky Panel had, running at 100% brightness. You can use this as a floodlight with its dome, or you can use it as a spotlight with its hyper optic attachment. Now that all sounds pretty remarkable, but there is some devil in the detail. Let's start off with the regular disclaimers. ARRI are not paying me any money for this review, but they did send me the product for free, and I do get to keep it or sell it. And that is something that you need to be aware of, because on some level that could possibly affect my opinion. Vice versa, there'll be people at ARRI crossing their fingers hoping that I can stay truly impartial, because I didn't have the best relationship with their previous management. Let's go through the pros and cons, and I usually start off with the cons first. But today I'm going to start off with the pros, otherwise some of the cons won't make any sense. Alright, so this unit has an IP66 rating, so not only could you use it outside in the rain, but if it got dirty, you could clean it with a garden hose. Now the other pro I've already mentioned is the massive CCT range. At the top end we've got 20,000 Kelvin, and all the way down the bottom end it goes down to 1,500 Kelvin. Now, I have to assume that it gets down to 1,500 Kelvin because that is actually outside of the range of a Sekonic color spectrometer. Now, the next pro for this thing, it has some incredible low-end dimming capability. Have a look here at the stats for 0.1%. Now, not only does that have some impressive CCT accuracy and color render results, but it actually is a true 0.1% brightness. It also has a high speed mode that is completely flicker free and completely dimmable. Now this panel light can be used as both a floodlight and a spotlight. It has 8 pixel zones. Now with the hyper optic attachment, these zones are really well separated and give you pixel effects like a fire even over a large distance. You can also get an adapter to use your existing S60C modifiers with this light. And in addition to that, it has a lot of support with new products from DOP Choice. It also has different modular mounting options. You can have 2 mounted together making a square, or you can have 3. Now initially I didn't like the user interface because it only has the one knob for adjustment, but after getting the hang of it, I found it to be an incredibly powerful user interface. I particularly like the menu systems. It is really easy to see what is happening in the menus without having to go into submenus. But I think the biggest pro for this light with the dome on is it is currently the only floodlight panel that could light up something large like a cyc wall, which has RGB ACL lighting capabilities, being able to generate more colors than our RGB lights could. So let's have a look at that with a comparison, this versus the Sky Panel S60C. For this color test, both lights are receiving the commands at the same time from the blackout lighting console. The center graphic is a screen grab from the console as the test is happening. The inside ring is an approximation of the color that should be generated by the light. Now just bear in mind with this test that my garage door isn't white, so it's not going to be 100% perfect, but it's close enough and you get the idea. Now let's get into the negatives, and after weeks of testing I could only find one glitch in all of the software, and that is with the DMX. The first time you cross over between a white light and a colour hue, there's a 2-second delay. Then after that, it will respond perfectly until you turn the light off and back on again. Now let's get to what I think is the biggest negative with this light. It is both a hard light and a soft light, or I prefer the terms flood and spot, but in its native mode with nothing attached, it is neither. If you want to use it as a soft light, well, you're going to have to put the dome on the front. If you want to use it as the spotlight or the hard light version, you're going to have to put the hyper optic onto the front. Now here's the obvious issue. This takes up a lot of space. The next thing you need to be aware of as a possible negative is that amazing low-end dimming that you get in the high CRI mode. So how did they achieve these fantastic results? Well, it's using pulse width modulation dimming. And at high brightness, it's running at around 32 kilohertz. Now that's pretty high frequency for pulse width modulation. So if I was on a shoot and they sprung on me a higher frame rate out of nowhere, I wouldn't really have an issue with that sort of frequency. However, in the bottom end of the dimming, it's only running at 1 kilohertz, which will definitely give you flicker issues if you end up at an unusual frame rate. So are we really going to use a light like this at a really low dimming rate at high speeds? Well, probably not, but here's my negative. It's the point at which it switches over, and that is at 25%. So at 25% and above, it's running at 32 kilohertz, and from 24% down, it's running at 1 kilohertz. For me, the issue is that high switchover point of 25%. I do a lot of jobs where someone in the agency suddenly decides they want to have the shot in slow motion. And these days, the cinematographer just pulls out the ND filter, fiddles around with the ISO, and we can shoot at reasonably high speeds without changing the lighting. And quite often when this happens, I've got lights that are running below 25%. Now, if this becomes a problem, you can just switch modes. You won't get that amazing low-end color render that you got before, but it's still going to be pretty good. And if you're running your set over DMX, this is even easier. In the profiles, under the control option, you can change your operating mode there. So again, not necessarily a negative, but something to be aware of. So if you're on set and you watch a playback and you can see some flicker coming from the SkyPanel X's, you know what it is and you know how to fix it. The next negative for me is the beam angle on the hyperoptic. 11 degrees. So this gives us a very fine spot with a lot of firepower, but for the sort of work I do, 11 degrees is way too tight. Now initially I was interested in buying this light because I had lots of SkyPanel S60C modifiers. So the idea of having an adapter that enabled me to use those modifiers was very appealing. However, at 700 Australian dollars per adapter, I gave up on that idea real quick. The next possible negative for people is the SSI scores. This has relatively low scores compared to some of the new released RGB ACL lights of recent times. If you're going to be using hundreds of these in a lighting grid and you're running them dimmed, just be aware that the power factor unity scores are also behind where a lot of our modern lights are. And at this price point, I would expect the screws that hold the terminals on not to be rusting. Let's do a walk around of the light and we'll start off with the front. So on the front here on both sides, you've got these releases, and those releases here hold the modifiers into place. So you've got this little notch that goes into the release on both sides, and then you push up to lock. So your modifiers are definitely held in securely. And the one thing I like about this is if you've got it, say, high up in a corner, you don't have to lower it down to slot it into the top. You can mount it directly from the front. But of course, that made it not compatible with your previous accessories from your other SkyPanels unless you had an adapter. Now, the only thing that sort of does concern me here a little bit is on the dome, the mounting point here and the little handles on the side are made of plastic, and they do feel a little bit pissy. Now on the front we've got our LED arrays, and this is in a weatherproof gasket, so it's very well protected, not only against the rain but against any damage that could happen to the front of the light. Now there is a lot of spacing between the RGB ACL LED clusters, and I'm guessing this was to allow space for the hyperoptic lenses. On the corner of the gasket connection for the LEDs, there are 3 threaded rigging points. Between the gasket holding the LEDs and the weatherproof compartments for the drivers and electronics, we have a massive heatsink. This is cooled by the fans pushing the air through from the back. Now these fans are IP66 rated, so there's no problem with them being used in the rain or water getting into this section. On the back left, we have our inputs. We have 2 local area network connections. We have a USB port for firmware updates. We have a connection for a display or user interface, which we'll talk about more in a second. We have our 5-pin DMX in and DMX out, and we have a 48 volt DC in for battery operation. Next to the input and output cluster, we have a status light. Now this status light can change color to indicate the CRMX state. Immediately below the inlets, we have a handle to help us with tilting the light. Above the inputs and outputs, we have a compliancy plate. So this has lots of useful information. For example, the most power you can run through the unit is 12 amps. It has your battery information and your temperature information. On the bottom right side of the unit, we have our power con in and through. Now one thing I really like here is ARRI has supplied a cable that is rated for the amperage on the power con connector, not the power usage of the light. And that is very important if you're going to use these cables to pass power through the light as well as operate it. Above our power connections is the user interface, and this is removable. You can get an optional cable which will connect the user interface to the back of the light, so you could operate it manually from the base of the light stand. On the top of the light we have a carry handle, which is very industrial looking but practical. On the stirrup we have a single disc locking mechanism with a ratchet handle. This is more than strong enough to hold the heaviest modifier. And it also has a tilt angle indicator. The stirrup is also removable so that the light can be used in modules. And as you would expect from ARRI, the stirrup is extremely well built and has no flex. Let's now have a look at this gigantic hyperoptic attachment. The hyperoptic has a very sturdy construction and a more than adequate safety rigging point. The lens system feels like it's made out of a plastic, and the 8 pixel zones are separated, so there's no spill in the hyperoptic. But one thing to note, this is a solid unit. It doesn't collapse down any further for storage. Let's have a look at the user interface, starting with the CCT mode. On the user interface, we have 5 buttons, which you can use to select your parameters and also do coarse and fine adjustments. We also have a knob for fine and rapid adjustments and also for selecting parameters and menu options. Displayed above the buttons are what the buttons do. The option above the line is what the button does if you give it a quick press, and the option below the line is what the button does if you give it a long hold. Let's have a look at our intensity. So here we can adjust the light in 0.1% increments using the knob. We can move fast and slowly, of course. We can also do 1% adjustments by pressing the buttons, and we can also do 10% adjustments. If we long hold the buttons, we can go to presets. Now let's have a look at our CCT or color temperature. Again, we can dial in our increments of adjustment using the knob, and this is adjustable in 50 Kelvin increments, all the way up to 10,000 Kelvin. Then above 10,000 Kelvin, it adjusts in 500 increments only. We can use our buttons to adjust in 500 Kelvin increments or 1000 Kelvin increments. And we can long hold to jump to presets. For example, 2800, 3200 Kelvin, 5600 Kelvin, 6500 Kelvin, and 10,000 Kelvin. Now let's have a look at our green and magenta options. We can do adjustments with the knob, and we can long hold to jump to presets. We can use quick button presses to do fine-tune adjusting, or we can do coarse adjustments. Now in our CCT mode, underneath intensity is extended color control. So if we long press the first button, we can jump into this menu. As you can see here, this gives us extensive control over our color settings. Now let's press the mode button and have a look at our operating modes. We've had a look at CCT, So now let's go to HSI. Again, we can use our buttons to select our parameters. Let's adjust our color hue. We can adjust our color hue in 0.1 of a degree increments. We can use our buttons to jump in 10 degree increments or 100 degree increments. And if we long press, we can skip to preset values. Now let's have a look at our saturation adjustment. Again, we can use the buttons for fine tuning or coarse adjustments. And we can jump to preset values. Now with a long press, we can also select more. That enables us to adjust our base CCT and green magenta value that we desaturate the light to. And also in this mode, we can go to our extended color control. Now let's take a look at XY. In terms of our intensity, we have the same control that we had in the other modes, in terms of the knob control and the button selections. We can select our X parameter, we can select our Y parameter, but we can also select our color gamut. We've got our usual camera settings of Rec 709 and Rec 2020, as well as some other color gamuts here. Other modes of operation include RGB ACL, we've got our gels library, we've got source matching, and we've got effects. Now I'm sure you're familiar with those items, so let's skip those and have a look at what Q is. So in the Q mode, you can save two looks or statuses. In status 1, I've got 5600 Kelvin dialed in with a neutral green and magenta. And I've got a red dialed in on status 2. In this menu system, we can set a time for a transition and dissolve between the two. Let's have a look. This could be handy if you need to do a transition, but you don't have any DMX control. And the last item in the mode menu is favorites. Here you can store and recall commonly used settings. Now let's take a look in the menu options. The first option is light control. Now one thing I really like about this user interface is on the display you can see what all of the parameters are set to without having to go into another sub-menu. The first option is our host client mode. Next thing in the menu is our operational mode. Here we can choose high CRI, high output, which reduces your color render, low noise, which reduces your output, and you've got some ARIA Alexa modes that you can choose. The next thing we can change is our dimmer curve, and we have the usual suspects. Next in the menu is tungsten mode on and off. This simulates the dimming characteristics of a tungsten light bulb. So for example, with this mode turned on, if you did an instant fade to black, the Sky Panel X would simulate the afterglow from a tungsten light bulb. Next in the menu is Q transition type. This has some options that I've never come across before in a light. Direct, through black, through white, over a white point, under a white point. Next is our high speed mode selection, which gives us a choice of on or off. Selecting on will remove the Sky Panel X from its pulse width modulation dimming mode, and it'll go into an analog dimming mode, which sacrifices color accuracy in your low end dimming, but gives you completely flicker-free light, regardless of the shutter speed or the frame rate selected in the camera. Now let's go back to the main menu, and our next options are in the DMX menu. Again, what I like about this menu is you can see all the parameters settings without having to go into those sub-menus. The other thing I like is with your DMX mode or DMX profile, it shows you that it's a 16-bit profile on the screen. Let's have a look at our modes and profiles, and we have a list of 24. We have our loss of behavior options, and we've got the usual suspects. Now the next one's got me a little bit confused, and that is mode specification 6.0. Now you cannot change the mode specification in here. Next in the menu is transition type, and I've got it set to direct, but you can choose through black, through white, over a white point or under a white point. This is all above my pay grade. Next in the menu is your termination on and off. So if you've got multiple lights linked together with 5-pin XLR DMX, and this is the last one in the chain, if you set it to termination, it'll stop the signal at the light and the signal won't bounce back down the line, giving you interference. Next thing down on the menu system is our RDM options. Next on the menu system is valid filter on and off. I've got no idea what that does. And you've also got DMX preset activation confirmation on or off. And finally, you can select your DMX smoothing. We've got a choice of on or off. The next thing in the menu system is our network settings. I don't use network settings, so I'm just going to slowly scroll through so you can see the options that are here. Next is our wireless options. Here we can turn on and off the CRMX. We can link and unlink the CRMX. We can see our signal strength. We can set our CRMX link key. It tells me that the controller that I'm linked to is transmitting CRMX Classic. We can also see the CRMX output name, and we can turn our Bluetooth on and off and enable or disable our Bluetooth code. Next in the menu system is our flash drive options. Here we can save and load different values onto a USB stick. We can load and save our favorites, our DMX user presets, our fixture presets. We can save log files and update the operating system. Next is our display setup, and that has the usual parameters for adjusting your screen. Next is fixture info, and this isn't just your firmware version. This has a lot of information that you could possibly need to diagnose problems, including CRMX and DMX issues. It tells us the status of the light, which you can also see on a status light indicator on the casing of the unit. We can see here that I don't have any data activity. So in other words, this isn't receiving any DMX or network information at the moment. We can see if the light is running off mains power or battery. If we had an error code, we can investigate it as well. And we can see the current power draw of the light. Next, we can see a readout of temperatures. This includes the CPU, the light engine temperature, and the LED driver temperatures. This information can come in handy if you're concerned the light is in a position where it's not ventilating. You can see if the light's getting hot before it becomes an issue. Next is our humidity levels, and then we can see the hours that the light engine's been running for and the system hours. This gives you some idea of how much testing I do on a Gaffer and Gear episode. We can see our firmware version, we can see our fixture serial number, and our control panel firmware version. On the next page down, we can see our IP address, ArtNet Universe settings, our DMX profile, DMX address, loss of behavior settings, and if our CRMX is linked or unlinked. And finally, you can see your RDM status. Next is fixture settings. Here you can change your language and do a factory reset. And the last button to cover is user. Here you can select what the buttons do. And the next option I know some of you will really love, DMX user presets. You can save multiple presets in here. So for example, if you're working on a job that has multiple locations or studios, you can have the DMX information already programmed into the light, ready to go. Let's have a look at the light with no modifier attached. And because this unit has native flood LEDs, it delivers a massive spread, which would make it absolutely ideal for softbox modifiers, such as your snapbags, lanterns, and even 5-foot domes. Because each cluster contains a full set of RGB ACL LEDs, illumination and color distribution is even regardless of the CCT or the color that you dial in. However, because of the spacing between the LED clusters, you get some serious shadow echo, but this could be a funky effect on a music clip. Now let's take a look at some spectrometer data with no modifier attached. When I dialed in 3200 Kelvin, I got 3179 with an SSI score of 77. The TN30 colour testing results were 95% average colour accuracy with an average 102% colour saturation. All of the CRI scores are plus 90. This is a spectrum distribution, and the white point came in with a delta UV of minus 0.0013, which would give the light a subtle magenta hue to a little bit more than the equivalent of 1/4 of a 1/8 correction gel. When I dialed in 5600 Kelvin, I got 5629 with an SSI score of 77. The TN30 colour testing results were 95% average colour accuracy with an average 103% colour saturation, with the CRI scores R9 is below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0021. So if you're working to the black body curve, the light will have a slight green hue to roughly the equivalent of 1/2 of a 1/8 correction gel, and if you're working to the daylight curve, then it would be slightly magenta to something like the equivalent of 1/4 of a 1/8 correction gel. When I dialed in 3200 Kelvin with no modifier attached and the light set to high output, I got 3178 with an SSI score of 76. The TN30 colour testing results were 90% average colour accuracy with an average 103% colour saturation, with the CRI scores R8, R9, R10 and R12 were all below 90. This is a spectrum distribution, and the white point came in with a delta UV of minus 0.0015, which would give the light a slight magenta hue to less than the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 5600 Kelvin with no modifier attached and the light set to high output, I got 5618 with an SSI score of 70. The TN30 colour testing results were 91% average colour accuracy with an average 101% colour saturation, with the CRI scores R8, R9, R10 and R12 were all below 90. This is a spectrum distribution, and the white point came in with a delta UV of plus 0.0020. So if you're working to the black body curve, the light will have a slight green hue to roughly the equivalent of 1/2 of a 1/8 correction gel, and if you're working to the daylight curve, it'll have a slight magenta hue to something like 1/4 of a 1/8 correction gel. Now let's have a look at how the light performs with the dome attached. And as you would expect, this gives you a massive spread. It removes all the shadow echo that we were getting off the individual LED clusters, but it has resulted in a reduction in light level. This would be ideal for lighting up large spaces, large cyc walls and backgrounds, and evenly illuminating blue screens and green screens. Now all of the spectrometer information for the dome is at the back end of the episode, with all of the other testing information. And as you can see, we are down to one soft shadow. And here it is used outside to give you an idea of the spread. And this is the spread over an even larger area. Let's take a look now at the hyperoptic attachment, and we'll have a look for any spill or stray light to start off with. And as you can see, this is quite clean. Now let's expose for the center of the beam and do some passes at different kelvins. Now this 11-degree beam does deliver quite a bit of firepower, and I do find it interesting how circular it is, given that the light is actually a rectangular shape. And the shadows, well, I don't think they would pass as sunlight. Now ARRI claim this is bright enough to use through a window, so let's give it a shot. With its 11-degree beam, it definitely gives you enough light to put some illumination onto a background, but it definitely doesn't give enough spread to give a full illumination of the room. And the shadow detail isn't there like you'd get off a good Fresnel, for example. Now for shits and grins, I thought I would try out the fire effect, because I was curious as to how the 8 zones would work with the hyperoptic. And it actually does a pretty good job. I've only got the one light, but if you had an array of 3 or even 6 of these, I think you'd get a really convincing fire effect through a window. Now let's try the hyperoptic attachment, lighting up my workshop from a distance of 8 meters away. And again, it doesn't have a massive spread, so it's okay for lighting up a background. And yes, it can do it, but there isn't a lot of firepower there compared to, say, some of the newer options that are available in high-powered COB. And again, for shits and grins, I thought I would try the fire effect. And even though this is at a distance of 8 meters away, it's not just fading up and down. You actually get the shadows licking from the 8 zones in the hyperoptic. And for giggles, this is from 20 meters away. And to give you an idea of the spot, here's the hyperoptic being used in a wider area. Now let's have a look at spectrometer data at 3200 Kelvin and 5600 Kelvin with the hyperoptic attachment. When I dialed in 3200 Kelvin, I got 3127 with an SSI score of 76. The TN30 colour testing results were 95% average colour accuracy with an average 103% colour saturation. With the CRI scores, R11 was below 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0019, which means at this point the light will have a slight magenta hue to roughly the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 5600 Kelvin, I got 5574 with an SSI score of 70. The TN30 colour testing results were 94% average colour accuracy with an average 103% colour saturation. With the CRI scores, R9, R10 and R11 were below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0026. So if you work into the black body curve, the light will have a green hue to a little bit more than 1/2 of a 1/8 correction gel, and if you work into the daylight curve, it's pretty close. When I dialed in 3200 Kelvin with the hyperoptic and the light set to high output, I got 3114 Kelvin with an SSI score of 76. The TN30 colour testing results were 91% average colour accuracy with an average 103% colour saturation. With the CRI scores, R9, R10 and R12 were below 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0022, which means if you don't dial any correction in, there will be a slight magenta hue to roughly the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 5600 Kelvin with the hyperoptic attachment and the light set to high output, I got 5619 with an SSI score of 71. The TN30 colour testing results were 93% average colour accuracy with an average 101% colour saturation. With the CRI scores, R8, R9 and R12 were all below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0026. So if you work into the black body curve, the light will have a green hue to a little bit more than 1/2 of a 1/8 correction gel, and if you work into the daylight curve, it's pretty close. Alright, so let's get into the DMX testing, and before we do, Just a reminder that my episodes are indexed and chaptered because the next 10 minutes is literally lights fading up and down via remote control. So pretty boring stuff unless you need to know about it. Now, just something I want to point out with the DMX testing, regardless of if I have this SkyPanel X running in its high speed mode, in its high CRI mode, smoothing on or smoothing off, or if I'm running CRMX or 5-pin XLR directly wired, if I'm doing a dim faster than a second, I can see by eye shimmering. Now, it doesn't show up on the camera, but it's there by eye. Now, I don't know why that is, but I can't get around it. Let's have a look at the testing. The SkyPanel X is receiving its commands via its internal CRMX receiver. It is set to a 16-bit CCT HSI profile, its dimmer is set to linear, and for the initial tests, its smoothing is turned off. To give you something to compare it to, I have a SkyPanel S60C. This has its original Gen 1 light engine. It's receiving its commands via an external CRMX receiver. It's running off a 16-bit CCT HSI profile. Its dimmer is set to linear, and it has no smoothing options. Both lights are receiving their commands at the same time via the blackout lighting console. This is transmitting the DMX commands via a Cerise CRMX transmitter. This is hardwired into the iPad and refreshes the DMX data stream at 41 Hz. Let's start off with instant on-off commands. Now let's do some half-second cues. This light shimmers more dramatically by eye than it does on camera. Now for some 1-second cues. With the 1-second cues, the SkyPanel X is shimmering by eye, which is barely perceivable on camera. Now for some 2.5-second cues. There is some slight shimmering here with the SkyPanel X, but it wouldn't concern me one bit if it was doing that on set. Now for some 5-second cues. Now for the rest of the testing, the SkyPanel X will have its smoothing turned on. Let's start off with instant on-off commands. Now for some half-second cues. With the half-second cues, the SkyPanel X is shimmering by eye, but I don't think it'll show up on camera. Now for some 1-second cues. With the 1-second cues, the SkyPanel X does look to be shimmering a little bit towards the end of its fade downs and the start of its fade ups. But this wouldn't concern me because from experience, I know that this doesn't show up on camera. Now for some 2.5-second cues. And 2.5-second cues appear to be beautiful and smooth by eye as well as on camera. Now for some 5-second cues. Now for some changeovers between 5600 Kelvin and 3200 Kelvin, starting with instant changeovers. Now for some half-second changeovers. Now for some 1-second changeovers. Now for some 2.5-second changeovers. And some 5-second changeovers. Now for some changeovers between a CCT and a colour hue, starting with instant changeovers. Now for some half-second changeovers. Now for some 1-second changeovers. Now for some 2.5-second changeovers. Now for some 5-second changeovers. Now let's do the Q tests again, but this time with the maximum brightness set to 10%. Now just to note for this test, the intensity displayed has 2 decimal places. Let's start off with some half-second Qs. Now for some 1-second Qs. Now for some 2.5-second Qs. And I think it's pretty obvious from this Q testing why so many people still hold on to their original sky panels. And finally, some 5-second Qs. Let's start going through the rest of the data I've collected now, starting off with AC power draw. And just to note, any spectrometer information given from this point onwards has been taken with the dome attached. The maximum power draw automatically recorded over the total duration of my testing was 663.8 watt. Running in its normal output mode at 100% brightness, I recorded 492 watt at 3200 Kelvin, and at 5600 Kelvin, I recorded 532 watt. Set to high output mode, it's pulling 579 watt at 3200 Kelvin, and at 5600 Kelvin, it's pulling 639 watt. And for those people doing large studio jobs running hundreds of these lights, I've recorded the power factor readings at both normal output and at high output. Now let's take a look at the dimming system. In its normal output mode, it is running pulse width modulation. From 25% and above, this is running at 32 kHz. But below 25%, it is only running at 1 kHz. So below 25%, it definitely won't be high-speed flicker-free. Now my meter couldn't detect any frequency in the high-speed mode, which means it is entirely flicker-free, regardless of your shutter speed or frame rate that you shoot at. Now let's take a look at the dimming characteristics. And these readings were taken with the light set to normal output and the dimmer option set to linear. I've taken readings at 100%, 75%, 50%, 25%, 10%, 5%, 1%, and 0.1%. The brightness is very accurate to the target dialed in. Across its entire range, the CCT is incredibly close to the target value, and the color render, measured in TM30RF, is a constant 95 all the way down to 10%, then it drops 1 point to 94, and green and magenta hue stays incredibly consistent. Now just note here, at 0.1% brightness, this is a true 0.1%, and it is still very usable as a key light. Now let's take a look at 5600 Kelvin. The brightness is extremely accurate to the target value dialed in. The CCT is incredibly accurate all the way down to 1%, and even at 0.1%, it's still pretty good. The color render, measured in TM30RF, is either a 95 or a 94. And the delta UV or green magenta shift is extremely consistent all the way down to 1%, and even below 1% it is still very good. Now let's take a look at the dimming characteristics with the light set to 5600 Kelvin running in the high speed mode. The CCT is very consistent all the way down to 5%, and then it does drift by about 400 Kelvin. Overall, the color render scores are down 1 point, and the delta UV, white point or green magenta shift is very stable all the way down to 10%. Then below that, it does skew towards green. But if you're running the high speed mode, chances are you're not using this light below 10%. Now let's have a look at the average CCT target accuracy. At 1500 and 1550, I don't have a reading because this is below the capabilities of my Sekonic meter. Now let's have a look at the color render measured in TM30RF. Again, anything below 1600 is outside the range of a Sekonic meter. Between 1600 Kelvin and 2250 Kelvin, it ranges between a score of 84 and a score of 92. Between 2300 Kelvin and 7000 Kelvin, where I stopped taking individual readings, the lowest score is a 94 and the highest score is a 96. Now let's have a look at the white point placement measured in delta UV. From 1600 Kelvin to 4000 Kelvin, this light is tracking just below the Planckian curve, or in other words, has a very slight magenta hue. From 4000 Kelvin to 5000 Kelvin, the light breaks away from the Planckian curve and starts heading up towards the daylight curve, which is why it doesn't have an average. Between 5050 Kelvin to 7000 Kelvin, where I stopped taking individual readings, the light is tracking between the Planckian curve and the daylight curve, favouring the daylight curve. Now let's take a look at some of the higher CCTs from 7500 Kelvin to 10,000 Kelvin, taken at 500 Kelvin increments. And now let's have a look at 10,000 to 20,000 Kelvin, measured in 1000 Kelvin increments. Now let's take a closer look at some of the kelvins with the dome on, starting off with the lowest CCT that we can dial in. When I dialed in 1500 Kelvin, this was under the range of the C800 colour spectrometer. It is also outside of the range for doing a TM30 colour test, and also out of the range of the CRI test. But at least I can give you a spectrum distribution. I can't give you a delta UV score, but at least I can show the XY coordinate. The lowest Kelvin I could dial in and get a result on the spectrometer was 1600 Kelvin, and I got 1603. The TN30 colour testing results were 84% colour accuracy with an average 107% colour saturation. But note, there is a lot of colour skewing here, with the CRI scores R8 and R9 were below 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0008, which is very accurate for such a low Kelvin. When I dialed in 2500 Kelvin, I got 2488. The TN30 colour testing results were 94% average colour accuracy with an average 103% colour saturation. All of the CRI scores were plus 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0017, which will give the light at this point a slight magenta hue to somewhere around the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 3200 Kelvin, I got a very accurate 3202 with an SSI score of 78. The TN30 colour testing results were 95% average colour accuracy with an average 102% colour saturation. All of the CRI scores are plus 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0017, which would give the light at this point, without any correction dialed in, a slight magenta hue to somewhere around the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 4400 Kelvin, I got 4440. The TN30 colour testing results were 95% average colour accuracy with an average 103% colour saturation, with the CRI scores R9 is below 90. This is the spectrum distribution, and the white point was very accurate with a delta UV of minus 0.0005. When I dialed in 5600 Kelvin, I got 5696 with an SSI score of 71. The TN30 colour testing results were 95% average colour accuracy with an average 103% colour saturation, with the CRI scores R9 and R11 were below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0019, which places it safely between the black body or Planckian curve and the daylight curve. When I dialed in 10,000 Kelvin, I got 10,371. The TN30 colour testing results were 93% average colour accuracy with an average 101% colour saturation, with the CRI scores R9 and R12 were below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0031, which means it's still tracking to the daylight curve. When I dialed in the top Kelvin of 20,000, I got 21,861. This is outside of the range of a TN30 colour vector test, with the CRI results R9 and R12 were below 90. This is the spectrum distribution, and the light is still tracking to the daylight curve with a delta UV of plus 0.0041. Now let's take another look at 3200 Kelvin and 5600 Kelvin with the dome on, but this time with the light set to high output. When I dialed in 3200 Kelvin, I got 3172 with an SSI score of 76. The TN30 colour testing results were 90% average colour accuracy with an average 103% colour saturation, with the CRI scores R8, R9, R10 and R12 were all below 90. This is the spectrum distribution, and the white point came in with a delta UV of minus 0.0021, which would give it a slight magenta hue to somewhere around the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 5600 Kelvin, I got 5670 with an SSI score of 70. The TN30 colour testing results were 92% average colour accuracy with an average 101% colour saturation, with the CRI scores R8, R9, R10 and R12 were all below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0022, which places it nicely between the black body curve and the daylight curve, favouring the daylight curve. Let's have a look at how accurately this light can dial in its primary and secondary colour vectors. When I dialed in 0 or 360 degrees or red, it was smack on at 0. 120 degrees or green was smack on at 120 degrees. When I dialed in 240 degrees or blue, I got 241. When I dialed in 60 degrees or yellow, I got 39 degrees, but it does look like a yellow. When I dialed in 180 degrees or cyan, I got 191. And when I dialed in 300 degrees or magenta, I got 287. Okay, so just my closing thoughts. The two big heroes for me with this light. Number one is the dimming capability with the high CRI mode. Even though it's not really flicker free, below 25%, I would have no hesitation using this as a key light if we were shooting standard frame rates. Even below 1%, I know I'd get really good color. And I think that's a big plus because quite often I end up with lights running at really low levels. You know, we start off at high levels at the start of the day, and then as the light levels drop, the ambient light goes down, we end up with the lights at stupidly low levels. And it's reassuring to know that I can get good color render out of a light in that scenario. The other big plus for me would be using this as a cyc light with its dome. Having that RGB ACL light engine, being able to get those super rich colors that I can't get out of an RGB light would have been an amazing plus for me. But unfortunately, it's a no because as you can see, it's not a hard light, it's not a soft light without a modifier on the front, and I just don't have the space in my vehicles to transport the modifiers. Anyway, I want to hear what you think. Do you like the light and why? Do you not like the light and why? And it's important to have your comments down because the manufacturers read your comments and they make changes on the next generation of lights based on your opinion. Thanks for watching Gaffer and Gear. See you on the next episode.